As humans, our bodies have very specific survival needs. And if these specific needs are not met, then basically we do die. So we want to go through the 5 human survival needs, the things that we always require. First up, the human body does require nutrients. These nutrients will be used to build different structures inside of our bodies, produce new molecules, produce new cells, function in the overall growth and development of our body. This is something that we are going to get from the food that we eat. So we constantly require a supply of food because we need these nutrients that's going to provide. Another basic function that we have is oxygen. We cannot survive without oxygen really for any real length of time. Just a couple minutes would be kind of the absolute maximum. Oxygen is going to be supplied by the respiratory system, which then works with our cardiovascular system to supply that to our various cells. But the reason why we need that oxygen so much is that the oxygen is going to assist with the breakdown of food, and ultimately that will provide our cells with energy. So without oxygen, we would not be able to supply our cells with the energy that they do require for their everyday functions. So oxygen is required all of the time. Another thing that's absolutely required is going to be water. Our bodies are made up primarily of water, 60 to 80% water, really depending on how hydrated you happen to be. And so that water, it's H2O. That is one of the reasons why we find so much oxygen and so much hydrogen inside of our bodies, is because this big abundance of water. Our bodies have to maintain an appropriate temperature. So the temperature for humans is going to be right around 37 degrees Celsius or 98.6 degrees Fahrenheit, if we're talking Fahrenheit. And so we really need our body temperature to stay very close to that number. If it gets too cold, then that's going to slow down the metabolism or slow down the reactions inside of our cells. And that is not going to be ideal for our cells. If it gets too hot, then it does speed up reactions. But the problem with getting too hot is that this will then start to break down some of those very important molecules that are running those reactions. So because of that, our bodies are really designed very well to work right around that human body temperature. So we do need to have mechanisms in place that are going to help us to maintain that body temperature. And then lastly, it is important that we maintain an appropriate atmospheric pressure. So this is going to be the pressure of the atmosphere on our bodies. Here on Earth, everything is good. But if we were to travel to space, that's why you do see astronauts wearing special space suits, because there is a different atmospheric pressure there in outside of the Earth's atmosphere. Okay, so these are the basic human survival needs. If we look at this picture right here, these pictures that we have on this slide, this is just illustrating to you, emphasizing what you already know, and that is the fact that the human body is good at doing a number of different things. We can participate in a number of different activities. We've got running or physical movement in the picture at the top. We've got eating in one of the pictures at the bottom. We've got sleeping and rest in the other one. And one of the things that I want you to get from this picture here, and the reason that I'm showing you these different pictures, is to emphasize to you that we are constantly doing different things. So what that means is that our body is subjected to different things, and we have to be able to deal with the fact that externally things are changing. So our body's way of dealing with a changing environment, changing activity levels, is going to be the process of homeostasis. So by definition, homeostasis is our body's ability to maintain a stable internal environment. And if we think about this, everything on the inside of our bodies is supposed to stay within an acceptable range. And this is even though on the outside, we just said we're changing things all of the time. The temperature is changing on the outside. How much food we're eating this morning versus later this afternoon is going to be different. So we've got different amounts of food coming in, different amounts of nutrients coming in. We have different levels of activity, which will affect how tired we are. Lots of different things that are changing throughout the day or from one day to the next day. And so with homeostasis, this is a crucial mechanism that our body uses to maintain that internal environment. So one way that I like to think about homeostasis is that this is kind of like our body's cruise control mechanism. So if you think about what you know about cruise control, that is this setting on our cars where we can set the car to go a certain speed. So I'll say 60 miles per hour. And then we expect that no matter what, our car is going to stay right around 60 miles per hour, give or take a few miles in either direction. And the idea is that it doesn't really matter what the road is like, we expect the car is going to go right around 60. So if you've used cruise control before, you've probably noticed that if you start to go uphill, the engine kind of kicks it up a notch. And you can hear that the engine is actually working a little bit harder when you start to go uphill. And that's because the car knows, or the cruise control mechanism knows that, okay, under these conditions, I have to work harder to maintain that set speed. And then at the same time, if we start to go downhill, you might notice that the engine seems to kind of slow down or taper off a little bit, because in that set of conditions, the engine doesn't need to work as hard. So the idea is that the engine automatically adjusts depending on what the conditions happen to be. And it does that automatically. That's what homeostasis is. Homeostasis is our body's way of maintaining some set level. It will have to make some adjustments up or down at times to maintain that level. And that is going to require the interplay of a lot of those different organ systems that we have gone through and talked about. Now, as far as the actual parts that are involved in what we would call homeostatic control, we have three main parts, and that's the receptor, the control center, and then also the effector. So these three are going to kind of work together, kind of a step 1, step 2, step 3 process to help us to maintain that constant internal environment. So if we look at an example here, we do have the receptor, which is going to be the initial thing that receives the input or the stimuli that something has changed or something has altered. This might be just the detection of a molecule, but it is going to detect that something is different from what it was before. And when it detects that change, the receptor is going to send that information to the control center. So the control center is going to collect that information and is going to process that information and decide what does it need to do with that information. So information going in is what we call the efferent pathway. And then the control center, again, it processes that information and then it sends that information out to the effector. So the efferent part right here, that is the information going out. The effector is going to actually cause the response. So it will affect something. And if you just look at the picture, the image here is kind of a teeter-totter or balance. And if something gets tilted one direction, we're trying to level that back out again. So that's maintaining everything within a very specific range that's going to be ideal for our survival. This temperature is one thing that we have to constantly regulate. So if our temperature gets too high, then there are processes in place to help cool us down. And one of those is the whole sweating mechanism. One of them, you may have noticed, if you get really overheated, your face flushes or you get a little bit red in the face. That's another one of those mechanisms that are in place to help cool us down. Blood sugar has to be regulated. Insulin's very important for that. And if you're a diabetic, you're very aware of that as being something that has to be regulated. So those are just a couple of examples of things that homeostasis would be maintaining. So the process of homeostasis is crucial to our survival. It is our body's way of maintaining a stable internal state. When things change, it's going to restabilize them. And this would be regardless of what's happening on the outside. It takes that information and it restabilizes. Homeostasis is so important to us that really when you get down to it and you talk about human diseases, most diseases do result from some type of imbalance in homeostasis. So from some inability of the body to maintain a constant internal environment. And I'll just mention diabetes as a very common example. Diabetes is an inability to control and regulate blood sugar within the range that it should be. So again, a perfect example how when homeostasis is just off and it's not working properly, we can have some very significant effects on our overall body.